On these first two, I recommend that we graph these, and so I attempted to make sure that everybody had graphing calculators. If you don't, look off of a neighbor. But we're going to type each of these into y equals. So my calculator is going to look a little different than you're used to, but it'll still work. I'm going to type in the first one, y equals x cubed minus 4x over 4x squared minus 4x minus 8. And this is a kind of funny looking graph. So what we wanted to do on this is find the holes in vertical asymptotes. Vertical asymptotes are right here where we have this up and down thing going on, where it's getting really close to this line and then it drops down to the bottom and keeps going. So that happens at -1. I can tell for sure that that happens at -1 if I go to my table of values. So on your calculator, go to the table of values right now, and what you're looking for is where we have errors. And there should be 2 spots on this one that you come up with errors. -1 and 2. So the deal is that some of those are vertical asymptotes and some of them are holes. We saw on our graph that the vertical asymptote was at -1. And so that means that our hole is at 2 because we can't see holes on our graph. It looks like a perfectly normal situation at 2, but really there's a hole there. A really, really small hole that you can't see with your eye. Questions on 1? Let's graph 2. So we've got 2 on top and x minus 4 on the bottom. And so it asks us on this one for vertical asymptotes and horizontal asymptotes. So vertical is up and down, and that happens at 4. You can check your table of values if you can't tell for sure what that point is. Our horizontal asymptote, we're approaching the x-axis, which is y equals 0. So our vertical asymptote is at 4, which also comes from where the bottom equals 0. Our horizontal asymptote is at 0. But I recommend you just graph those, look at the graphs, and on the first one we had to look at our table of values also, but that should get us the answers on those problems. So some of these we can type into our calculator. The y equals ones we can, but x equals, it makes it actually kind of harder to just try to type it into our calculator. On all of these though, just by looking at it, we should be able to tell if it opens up or down and left or right. If it's y equals, it's up or down, and if it's positive in front, like this first one, doesn't have anything in front of my parentheses, that means it opens up. Here I have a negative in front, so it opens down. On the next two though, where I have x equals, instead of up and down, it's left and right, but it still has to do with their negative and positive. This is negative in front, so that opens the negative x direction, which is left. This is positive in front, so it opens the positive direction for x, which is right. And now we'll go back and fill in our vertex for each of these. Our vertex comes from the number inside and the number outside. We change the sign of what's inside, but we don't change what's outside. So this is 7, 8. And this one would be 6, -5. And just in general, for this test, you need to remember, if something's in parentheses, it's going to change signs whenever you write it down. For x equals, my vertex is switched around. This is telling me my y value, and this is telling me my x value. So this is 7, -5, not the other way around. And that is how they'll try to trick you on these questions, is because -5, 7 will be an answer, and that's not right. So this one would be -8, +2, because it switches around when it's x equals. On 7 and 8, we're trying to figure out what we can multiply by that will get rid of our denominators. So to get rid of this first denominator, I would have to have a 3 To get rid of the second one, I'd have to have an x. To get rid of the third one, I'd have to have 3x. So let's do 3x over 1, because that'll get rid of all of them whenever I multiply it through. So then we think about 2/3 times 3x over 1. Well, the 3's cancel. So we would get 6x over 3, which simplifies to be just 2x. And then we're going to keep going. I'm going to do 1 over x times 3x over 1. And here my x's cancel. And so that gives me 1 times 3 on top. So it equals 3. Then I keep going. X minus 4 over 3x times 3x over 1. Well, now 3x and 3x cancel out completely, so I'm left with x minus 4. Then I solve this like a normal equation. Now this is from like 2 chapters ago, and the reason it's still showing up is because we still keep missing these problems, even though they're really not that difficult once you get the hang of them. And so the problem is that some of us are, I don't know, ignoring that they exist and hoping for the best, and so far that hasn't worked out very well for you. So I recommend you change tactics and try to learn how to do it. 3 minus 4 is -1, so x equals -1. Okay, so number 8. We have to figure out what to multiply by that'll cancel out all of our denominators. So one thing you might do is pick the biggest denominator, I guess you would say, like 4n. Will 4n cancel out these other 2 denominators? Which it will, because it'll cancel out 2n and it'll cancel out n. So that's what we want to multiply by, is 4n over 1. So let's do that. Multiply everything by 4n over 1. You could write it all out and then start canceling, or you can cancel as you go. I mean, it's kind of whatever. I'm just going to write it all out. You don't have to. If you can cancel out in your head, then that's fine. Here the 4n's cancel, so n plus 4 is left on top. Here, n definitely cancels, and then what can I do with 4 and 2? What cancels out of those? A 2, so that leaves me with a 2 on top. 1 times 2 is 2. And then on the last one, what cancels? The n's, and so we have to do 4 times this, and you have to distribute that. Okay, it's not just 4 times 2, it's 4 times n and 4 times -2, so that'll be 4n minus 8. All right, solve. So get n on one side. Two minus 8 is -6. Where? Here? Negative 3n plus 4 equals -6. And then we subtract 4 from both sides. Wow, it's much harder to write when I look at the smartboard. Okay, -3n equals -10. Divide by -3. And our answer is n equals 10 over 3, because the negatives cancel each other out, but nothing else simplifies.
You sure?
I'm positive. I'm pretty good at this. We could also write this as a decimal, which would be 3.33 repeating, and that would be fine. If it's multiple choice, though, our answer that we're looking for will probably be 10/3 as opposed to 3.333333333. 3, 3, because we had a negative divided by a negative, which makes a positive. In math and English, but not in real life. 2 negatives make a positive. Number 9. Use the information provided to write the vertex form equation of each circle. So a circle has x, and then has y, and then equals our radius squared. And so we're going to plug in the points for our center. Remember, it changes signs because of our parentheses. and then it equals r squared. R is 4, so it equals 16. Now for circles, you don't divide by 16 to get 1 on the right side.
Where'd you get 16?
I squared 4. The right side is the radius squared. And that's all there is to that one.
How did you get 6? So do you change like both the signs of the...
Both of these signs changed because they're both in parentheses. The radius had to be squared, so it would be r squared on the right. Okay. Number 10. Identify the center, length of the major axis, and length of the minor axis. So the center, we just grab these numbers. This 5 and 3, we change their signs because they're in parentheses. Now, the major and minor axis comes from these bottom numbers. We have to square root and then double the numbers on bottom. So we square root and get 9 and 12, but that only gives us part of the major and minor axis. So we have to double it to get all the way across. So the major one is the bigger number, which will be 24 when we double 12. And then our minor will be 18 when we double 9. All right, let's write some equations. So what's important here is our center, which is 4, 3, because that lets us, since this is an ellipse, this is going to be where we have fractions. So we have x minus 4 squared over something. Ellipses are plus in the middle. We have y minus 3 squared over something equals 1. Just being able to get that far will at least probably get you a 50-50 chance on what the right answer is. Now let's figure out what we're going left and right and up and down. Now how much does this go to the left?
4.
If I just want to go left from the center, how much does it go? It actually goes 1 because look at my scale down here. So that's tricky. There are 2 spots here, but that equals 1. If you look at your scale, to go from 4 to 3 is 1. So underneath x, we're going to square 1, which, by the way, is 1. Which means that I can just get rid of this fraction since it's over 1. Okay, sorry, let me go back. Leave it? Okay. And then how much am I going up? There are 4 spaces, but that's 2 units because each space is a half a unit. So we square 2 and we get 4. Oh, I see. Yeah, skipping ahead. Okay, so here's our answer. If this is multiple choice, it won't have 1 on bottom on this front fraction probably. Okay, because over 1 is just not a fraction anymore. All right, 12. We need our center, which is here at 0, 2. We need our radius, which is 6 spaces, but that's 3 up or left or right or down. It's all the same, which is why it's a circle. So we're going to do x, minus 0. I don't need to put parentheses when that happens. I need to just put x squared plus y minus 2 squared equals r squared. R is 3. So I square 3 and get 9.
Will you do that again?
Okay.
Yeah, you went so fast.
My bad. All right. I find my center point, which is 0, 2. And that's what's going to go with x and y up here. So since I would have x minus 0 in my parentheses, I don't need the minus 0, so that's why I just wrote x squared. And then I wrote y minus 2 squared. Then I think about what's my radius? How far is it from the center to one of these sides of my circle, which would be 3. On the right side of this equation is r squared, so I had to square 3 and get 9. And then it's a circle, so I don't have to do anything else. Number 13. A hyperbola. So on your review, it might be kind of hard to tell where the top of the box and the bottom of the box is, and it should be easy for you to figure out because the top of our box has to meet the left and right side of our box, like where this line is going through the corner. So I can't make the top of my box be up here because then that line wouldn't go through the corner of that box. So if it helps you to outline that box because it didn't outline well enough on your paper, then please do. Because what we need is the center of the box where the X crosses. Like look there, it looks like an X, and so the center of that is at 1, -3. We're going to put that into our equation for hyperbolas. Now, one thing we have to do with hyperbolas and say, should X be first or should Y be first? And the way I know is if it's left and right like this, X is first. But if it was on the top and bottom of my box, that's when Y is first. So I know it's going to look like this when I put in my center point. And like I said, this would probably get you a 50-50 shot if you can at least get that far. Now we've got to figure out what goes on the bottom, which comes from our box. How much am I going to the left to get this box from the center? 3. So I'm going left 3. I square that and put that on bottom and get 9. I'm going up 1. So I square that. 1 squared, just an FYI, is 1, not 2. 1 times 1 is 1. And then just like before, you can take the over 1 out of that because it's kind of repetitive and not needed.
2, wouldn't you square 2?
No, I went up 1.
Oh, okay.
And so I square 1. No, if you're using the whole way across, you have to divide that number by 2 before you square it, which is fine. But if you're saying, oh, it's 6 all the way across, you have to half and square it. And that's how we get 9. 14. We've got an ellipse. We know the center. That's helpful. Let's put that in. Ethan, do you have a question? No. Okay. You can see how I got confused.
I understand. Definitely not.
Okay. If they tell me the height and the width, they're telling me the whole height and the whole width. And I just kind of gave away what I was about to ask you. Height is which direction? Up and down, right? And then width is left and right. What's up, Brian?
How do you know if it's like in between the parentheses, if it's a plus or a minus right there?
Ellipses and circles are pluses. Only a hyperbola should have a minus sign.
Okay.
That's what makes hyperbolas special. So if it's 16 for my height, then I need to divide that by 2 so that I can get how much I went up and down. So that's 8, and then I square 8, and that's what goes on the bottom of y, because height has to do with y, because it's up and down. So we half and square 16 and get 64.
49.
And then we half and square here and get 49. Voila, that is it.
Wait, why do you have to half and square it? Why don't you just use the
Half and square. Half and square.
Because it's all the way from the top to the bottom of my ellipse is 16. And so if I just want to think about how much did I go up, that was 8. And then that's the number I square.
If we like do the wrong equation or wrong, do you still get like half credit or something?
Probably. I mean, it depends on if it's multiple choice or not, right? So partial credit comes from you doing things that are kind of right. And so if you do something that's kind of right, you get partial credit. If you do stuff that's completely wrong, you don't. So, okay, let's write some parabolas. What I care about most here is my vertex, which is 4, -1. The other thing I need to know is that it's opening up. And those are the only things I need. Oh, actually, this was supposed to say assume A is 1 or negative 1. And so in our standard form equation, not standard form, in our vertex form equation for a parabola, it says y equals, and then we have a here. And so a is positive when we open up or right, and it's negative if we open down or left. So this should be a positive 1 in front of our parentheses, or you don't have to put anything in front of your parentheses because 1 is not needed. Then I'm going to put x, and I put minus 4, because that's my x value. And then I put minus 1 on the outside, because remember, outside my parentheses, I don't change the sign. So this would be my equation.
How do you know to put 1 where A is?
The instructions were supposed to say that a had to be 1 or negative 1. And so then you decide between 1 and negative 1 based on if it opens up or down.
Oh, okay.
So if you get one that opens down, we should have a negative 1 in front. Or if I have one that opens left, it would be a negative in front. But these both opened the positive direction. Like here, I'm opening to the right, which is positive. The vertex is negative 6, 4. Since it opens right, instead of y equals, we put x equals. Right is positive, so we put positive 1. In my parentheses, I put y, and so I'm not going to put the negative 6 in. I have to put the 4 in right here. Yeah, the 4 in. And so that's our answer. Number 17 is from our last test, and I'm going to give you this formula, or whatever formula it is that you need to do the problem. Maybe it'll be different, but probably not. This formula lets us find any term for an arithmetic sequence. All we need to do is figure out A1, which should be easy. That's the first term. And then the common difference, D, is what am I doing to get to each of these? Negative 10, minusing 10. I'm subtracting 10. And so now I can fill this in. AN equals 33 plus n minus 1 times negative 10. And if this was free response, we would stop here and say, hey, this is my answer. If it's not free response and it's multiple choice, they might decide to distribute this. So let's just practice that real quick. If I distribute the negative 10, that gives me negative 10n plus 10, and then I would add like terms. AN equals 43 minus 10n. So it could be that on a multiple choice question, that's your answer instead of the one up here. You wouldn't have like both and have to pick which one was right, but you'd have one or the other of these and you'd need to pick it. 18, 19, and 20 I would think would be the hardest stuff on this test, but we've done completing the square a whole bunch in this chapter. And so if you've actually been doing it like you're supposed to, this really shouldn't be that hard. We classify each conic section, and then we're going to complete the square to put it in the right form. So if I have a 4x squared and a 9y squared, that makes this be what kind of conic section? It's an ellipse. Circle is a good guess, but since they're different numbers, that's what makes it an ellipse. So we're going to complete the square. I'm going to put my 4x squared and my negative 8x together, but we have to take that 4 out from in front of x squared, so let's go ahead and do that. I'm taking the 4 out of my x's, so that gives me x squared minus 2x in parentheses. And then I'm going to group my y's together. What do I need to take out of my y's? 9, because that's the number in front of y squared. And then that negative 104, we're just going to move that to the other side since it doesn't have an x or a y. To move things, we have to either, since this is minus 104, I have to add 104 over to the other side. Now this is the part where we remember good old Professor Hoffen squared, because he tells us to take the number in front of x, Hoff it, and square it. So in this blank, I should put a plus 1. And then I say, what did I really do to this side of the equation when I put a 1 inside of this parentheses? Since there's a 4 on the outside, I multiply and get 4. Then I Hoffen square for y. And get plus 4. So 9 times 4 is 36. Now I wrote these down. The 4 and the 36 I need to put on this side so that my equation is balanced. I can't just add a number to one side of my equation and not do anything to the other side. That'd be silly. Now we're ready to factor. So we're going to write 4, and then this parentheses, if I factor it, I want to know what multiplies to get 1 and adds to get negative 2, which is negative 1, which is that number right there we got when we halved. And then I do y minus 2 in this parentheses, because it's what multiplies to get 4 and adds to get negative 4. We add up these numbers on the right side. 104 plus 4 plus 36 is 144. Some of you guys have already noticed, because of questions you've asked me in the past, if you get a number here and then when you divide you get stuff that doesn't work out to be nice numbers, you did something wrong. Do what? Yeah, we do divide because this is an ellipse. Ellipses and hyperbolas, we divide. Circles, we do not.
If we divide on a non-ellipse,
I would just take off like a little bit and not very much. What am I doing? So 144 divided by 4 is 36. And 144 divided by 9 is 16. And that equals 1. And so we're done. 19. Complete the squares. Oh, wait. What is this if we've got 9x squared minus y squared?
That's a hyperbola.
Hyperbola. Well, that's poor space management on your part.
Wait, so you put a minus against what? You put a minus against
The minus is a hyperbola. Because in between x squared and y squared, we're subtracting. Or if it had said negative 9x squared plus y squared. If that was a negative in front and the y squared was positive, that would also still be a hyperbola. Now let's group and factor and do all this good stuff. So I'm putting my x's together, but I'm going to go ahead and take out the 9 to save myself a step writing. And then I have negative y squared and 2y. I have to take the negative out of the y squared. I can't just leave it as a negative inside. Well, not if I actually want to complete the square correctly. And then I'm going to move 26 to the other side by subtracting. Because it is a positive 26. To move it, you minus 26. I really hope that if nothing else, we can all figure out what goes in these blanks. I half and square 4 and get 4. I half it and get 2, square it and get 4. I half and square negative 2 and get 1. But I really just did 9 times 4, which is 36. And I did negative 1 times 1, which means I need to put minus 1. So 9 and then x plus 2 minus 1 and then y minus 1 equals negative 26 plus 36 minus 9, which is 9. It is a number. It's a number called 9.
so
Well, when do we divide and when do we not divide? Ellipses and hyperbolas we divide, circles we don't. So I'm going to divide everything by 9 and get for my final answer x plus 2 squared over 1. Oh, I don't need to write over 1 because that's just over 1. And then y minus 1 squared over 9 equals 1. Anyone still writing, or am I okay to go on? Ready, set.
Wait.
Yeah.
Why? Oh, I'm writing.
Okay. Okay, 20. See if you can figure out which kind of conic section it is. See if you can do that if you haven't already. X squared plus y squared means it's a... Well, it's kind of like an ellipse, except it's a circle. Okay, if it's the same number in front of both, or no number in front of both, like this, it's a circle. We're not over there yet. We're on 20.
It can't be D because that's not an option. You're right.
Group your x's and your y's. There's nothing for us to take out of these, so that's nice. Half and square, 4. Half and square, negative 6. Put those on the other side to keep your equation balanced. In our parentheses, we need to factor. And then on the right side, we need to add negative 8 plus 4 plus 9, which is 5. Now it's a circle, so do I need to divide? No. All right, so on these last 5, because they're multiple choice, there's like a key thing on each of these that we would look for. Like on 21, since it's y equals and we have positive x squared, which direction should this open? It's either right or up, and since it's y equals, it's up. And if you weren't sure, since it says y equals, we could graph this and see that it opened up. So it has to be A because that's the only one that opens up. How neat is that?
What a view.
22. If you look at all the answer choices and kind of see what's in common, then that tells you what you don't have to find. All of these have a radius of 2, so we don't have to worry about the radius, but they have different centers. So this is a center of 2, 0, which means our answer is B, as in belligerent. B is in butte, because it's a butte. There's a back. 23. Look at all your answer choices. What's different about one of our answer choices? Okay, one's a circle. Do we think this should be a circle? No, so it's not B. What's different about another answer choice? One of them is really flat, and then the center of one of them is different. So should the center be at 0, negative 3 or 0, positive 3? 0, negative 3. So D can't be it. It has the wrong center. And so yeah, it's basically going to come down to is this a flat ellipse or a not as flat ellipse?
Not as flat.
I think you're right, not as flat, because we square root this and get 7. We square root this and get 3. We should be going left and right 7, which they both do. Well, actually, that only goes left and right 6. So that's wrong all the way. It's C, because it goes left and right 7 and goes up and down 3, which is what we want. Left and right 7 for a total of 14. Up and down 3 for a total of 6. Now this hyperbola, on 24. All of them except the first one are the same as far as which way they open. So since y squared is first, should I do left and right or top and bottom? When y is first, we do top and bottom, so it can't be a. We can square root these numbers on bottom to see how wide and how tall our box should be. Yeah, it can't be B or D if you go by that, because we need it to be 4 wide because it's underneath X and 10 high. So this is not 4 wide, and that's not 10 high. So it has to be C. C is in catastrophic conundrum. And finally, the moment we've all been waiting for, number 25. X equals a negative means it opens which direction? Sideways or left, to be more specific. That means it can't be B, and it can't be C. So then what is our vertex here? This is telling me my y value is -4, my x value is +2, which means it's A, not D.